the little Minecraft compiler. So here you can see this is what the source code is. Okay, I don't know how in depth I'm going to go, but each file should have a name value, right? And this is what is used to identify the variables later. So this is what the resulting code looks like. So everything is relative to this name, so that's like relative to the file. So when we create a scoreboard, like this input here, we can see that it adds a scoreboard, right? And then we will create our score relative to the scoreboard. So inside of our collection, when we make a score for the scoreboard input, then it will be relative to this input, which is relative to this file, right? We also have data-refs, which are for the Minecraft command / data like get block, and then you can get like a block where you can do / data get entity storage, right? And then so there's like reference, so data-ref, name type, what type it is, and then whatever the input conditions are. So like if it's a person, like you do data-ref entity at e, so that would be everything, right? And then you have positions, which are just an abstraction of like /set, right? Like this is a position, or /fill is a position, and then another position, right? And then you can have absolute positions, which are relative to where the original command block that summons all the rest. And then we have always blocks. So this is an initial block. This runs at the start, right? And then we have an always block, which is running continuously. And I've set it up so that they can have an expression inside of them. So what always happens is that this score value inside of our scoreboard gets assigned to the reference for this position, which is a block, and it gets page. So inside of the Minecraft world, that refers to this lectern over here. And then we have a little case statement that goes on the score. This actually gets turned into a bunch of if statements, but I feel like case statements are easier to read, and I felt like that was like a good language feature, especially because of how Minecraft works using like the match command. So like you do like 5 to 7, right? Or like then given a position, right? So line is a position, as you can see. You can call setBlock on a position. You also can call like fill and then pass in another position, right? And then we're filling it with air. So if it's 5, this was just for testing the multiple case statements. But if it's 0, then we set is 2 plus to 0. If it's 1, 1 is 0. Then alternating, and then for 3, it's both of them. And this produces from the lectern, it turns into binary, right? And then in the end, we just have something that sets relative to start, which if you remember is an absolute position, so that's relative to the starting command block. It sets it to lava, and the way that the commands are generated is it produces a bunch of command block minecarts, right, that are passengers of an activator rail, so that all these command block minecarts will summon command blocks with commands in them of differing types and facing in different directions, right? And then the last one will just get rid of all the minecarts, so they don't like continuously be running commands inside of them. So you compile that, right? And let's go back over into the game. So right now, if we go into the lectern, right, what the command should do, or what it will do, right, is if we're on page 0, then it'll set it to nothing. If we're on page 1, 1, 2, 2, 3, 3, right? So let's set it into an erroneous state, right? And then let's go over to where the command block that I have just like placed down over here is. So if we go over here, we grab that command, and we stick it in, right? Click the lever, command block spawn, lava spawns, deletes the blocks, right? Okay. So now, if we go back over here, we'll see that indeed it cleared out this thing. And if we flip through the pages, it'll set up the state of these blocks according to the pages. So, as a little demo, I'll set up something else, I guess. What should I set up? I don't know, what's a good thing? Let's make like a little 7-second display, I guess. So at this point, I started working on implementing the 7-segment display. You can see here about designing how I should make each of the parts of the display associate with each number. And then I started outlining the red code. It still supports the matching ranges supported by Minecraft, so 0 dot dot would match against everything above 0. You can see I have a little compiler issue, and the error, as it turns out, after I do a bunch of debugging, is that I did not have the proper name. I misspelled it. I did deminal instead of decimal or something like that. And then I generated my command, and it turns out that there's a maximum length of a command block, which was just really annoying. So I tried a solution where I would break the commands up into chunks, and it would automatically generate those differentiated chunks. So like it would do 100 blocks in one command, and then it would generate the next 100 blocks, and they would all go into each other. And this ended up working after a bit of fiddling around. So right now I'm implementing that solution. The only problem is that it generated this really long line. And previously I thought that the way that chain command blocks worked is that you could like pull if statements vertically out of a horizontal line. So I'd already implemented a kind of structure to make the command blocks fold in on each other. And I sped it up even more because it's just, you know, me programming, and not particularly good programming either, just work. At this point, yeah, you can see me fiddling around trying to get the folding back to work. So soon I'll realize that you can't set custom properties onto block entities that are already owned by Minecraft. So like I was trying to add numbers as a member to a furnace, and that didn't work. There are a couple of solutions to this. One of them is to use the storage entity type, and that's a pretty good solution. I kept adding language features throughout this period, so I think this was about almost 5 hours of work. I want to rewrite this properly. I think that'll be a fun problem. Actually add a proper either recursive descent parser or a prop parser to this so that the red language I wrote would work. Oh, you can see here I added that always blocks, or maybe I'm adding this at present. Always blocks will allow you to put multiple statements as the always statements. You can have multiple repeating command blocks defined in that area, and then you'll have your chain command blocks
set externally. I think setting things to not be activated by Redstone actually makes the game run quicker, though I'd have to benchmark this, because they can be treated as a separate system, which I think is what the game does. You don't have to do a block check every tick on each of the blocks to see if they would work. They get probably processed in a different part of memory, same place where the data packs probably get processed. Now we're going into 128 times speed. As I was saying though, adding a proper parser and then adding actual blowering. So I think it'd be pretty easy to add LVM IR lowering or Mylar lowering. Though something I haven't solved yet is doing functions